All right, so I wanted to talk in this video about our systems of equations, and we're just getting started on the unit. And really, what it's doing is taking the skills we learned when we just did one linear equation at a time, either mx plus b or standard form. And now we have situations where there's two equations at the time, and we want to see where both of them cross over. And so I want to talk to you about just a word problem, and I want to show you kind of how you might solve it in several different ways, and each way might build up in complexity. And so here's a situation. Let's just make up two names. Let's just say, okay, Ansel and Jeremiah. Um, let's say they have some coins. And what we're going to do is we're just going to keep track of how many coins they have over time. Each day, Ansel gains 3 coins and Jeremiah loses 1 coin. Ansel starts with 20 and Jeremiah starts with 52. When will they have the same amount? I'll just say, when will they match? Okay. So it's a situation where they start with different amounts, they change by different amounts, and eventually they will end up with the same amount. And I know they're going to end up with the same amount because Ansel starts lower and Jeremiah starts higher, and then Ansel's gaining, Jeremiah's losing. So it's somewhere in the middle, they're going to cross over each other. One strategy that you might use, and I've seen a lot of students who sometimes they struggle with doing the algebra, but they're able to solve it this way. And it's just by thinking about the gap. So if you think about the gap at the start here, the gap at the start, all right, gap start, is just, well, Jeremiah has 52, Ansel has 20, so we can figure out how far apart they are. They're 32 apart at the start. And the gap changes by a certain amount every time. So I'll write that as the gap change. All right. Well, we subtracted their starting values to figure out how much their gap start was. So let's subtract their change values to figure out how much the gap changes by. But be careful here. I can't do 3 minus 1. That would mean that their gap is changing by 2 coins each time. But it's actually not changing by 2 coins. If you think about it, because Ansel gains 3 and Jeremiah loses 1, they're actually getting 4 coins closer. They're getting 3 coins higher from the bottom, but 1 coin lower from the top. So that actually decreases the gap by 4. One way you can show that is by saying 3 minus negative 1. Some people don't like saying 3 minus negative 1. They'd rather say 3 plus 1. They'd say 4. Some students are able to just say, okay, it changes by 4 every time. And so that means that the number of days should just be 32 divided by 4, which is 8 days. Okay? So that's when they will match. And this is a strategy I've seen a lot of students do who maybe have a harder time with some of the other strategies. But what I want you to pay attention to is how the math that I did there matches up with what we're going to see in some of these other strategies. So strategy number 2 is making an XY table, but I'm actually going to make an XAJ table because I have two different Y values. I have the Y value for Ansel and the Y value for Jeremiah. I start with day 0. Ansel has 20. Jeremiah has 52. Then we can do day 1. What does Ansel gain? 3. Jeremiah loses 1. So you can see how they got 4 coins closer. Day 2. gain 3, lose 1. We can keep going. Gain 3, lose 1. I don't know how, well, I do know because I figured it out, but we're going to keep going until they meet. Gain 3, lose 1. You can see they're getting closer. Gain 3, lose 1. Gain 3, lose 1. Getting close now. Gain 3, lose 1. It's kind of nice to watch the numbers converging like that. Gain 3, lose 1. So, pros and cons here. You just had to be able to count up by 3 and count down by 1, and then you found the place where they met. So, in some ways, it was a little bit easier than the first strategy, because on the first strategy I had to do like a minus negative, and that was a little weird. On the other hand, it's more writing, and that's kind of annoying. And it needed to land on a nice whole number. If they had like met at 7.5, it would have skipped over that. You would have seen Jeremiah on top on day 7, and then Ansel on top on day 8. So that's kind of a drawback of this strategy. So I think it's nice because you're just counting, but it also has a little bit of a flaw because you have to hit it on a whole number. Okay. So strategy number 3 is to write them as linear equations. So let's try writing them as linear equations. I'm going to zoom out a little bit. And great. And let's erase everything. No, let's just erase some of it. No, change my mind. We'll just type it in. You'll be able to see it. So if I look at Ansel, I could either write y equals, or I could write a of x equals. That's a fancy way of just saying this is Ansel's equation. If you want to write y equals, that works just fine. So Ansel starts with 20 coins, and he gains 3 coins every day. I could have also written that as 3x plus 20 to think about it like mx plus b. And you can see the red line is going, the red line is going up 3 and over 1, and it starts at 20. All right, the next line is j of x. J of x starts with 52 coins and loses 1 every day. And you can see that those two lines cross over, and you can see that 8, 44 means that after 8 days, they meet up at 44. Let me actually delete everything. It's probably harder to see. So you can see now what I'm talking about. 8, 44. Okay. So graphing is a good idea. If you don't have the Desmos, you can use the yellow calculators, the TI calculators. They'll get it done too. So make sure you see me about how to make those things do what I just showed you on the computer. And there's one last way. The last way is saying, well, the number of coins is y. And my question is, when does Ansel's coins match with Jeremiah's coins? So I can actually make them equal each other. When does Ansel's coins equal Jeremiah's coins? And then we want to get our x's to hang out on one side. And we want to get our numbers to hang out on the other side. Now, if you've been paying close attention, you will notice that the math I just did algebraically is the same exact math that I showed you in strategy number 1. Notice that I had a change of -1, and the way I canceled it out was by doing adding 1. Well, what does that mean? My change was +3, and I added 1, so now my gap is changing by 4. That's what the 4x represents, just like in strategy 1 at the beginning of this video. The second thing I did was I got rid of a +20 by doing a -20. And that means my gap start is 52 minus 20, which is 32. Then I have a gap change of 4, so I divide by 4 to solve and get x equals 8. The last thing that I can do with x equals 8 is I can plug it in to Ansel's equation, and I can plug it in to Jeremiah's equation, and I'll see that Ansel's equation becomes 24 plus 20, and Jeremiah's equation becomes 52 minus 8. And both of those come together to make 44. So 4 different ways to solve this same problem. Think about pros and cons of each of them. Some of them are maybe more intuitive, some of them are more algebraic, some of them are more writing, some of them are less writing, some of them I use technology. So pros and cons for each of them. Please let me know if you have any questions or comments, and I'm happy to help.